Welcome, folks. What I'm just going to go over is just a little bit of the topic of today, and then Dave and myself will introduce ourselves, a little bit about what we've been doing in this space. I'll then introduce weather and construction, just to start giving a bit more of an overview. Dave's then going to run into some of the common approaches today in terms of scheduling and risk. It'll flip back to me and I'll talk about my favorite topic, the scary topic, climate change. And then Dave and I will both tackle the topic of how EHAB and Oracle are integrating together. And of course, if there is time for discussion and conversation and questions at the end, then we'll jump in. So I'm Josh. Really good to meet you all. I know some of you but I'm the founder of EHAB. So we're a little startup based here in the UK. We've been working with a lot of big construction companies for a number of years now, developing a tool that we think is really valuable in terms of helping contractors understand better weather and climate risk. So yeah, really excited to have you all on the call. Dave?
Yeah, thanks, Josh. So yeah, Dave Hammal here. My role, as you can see, I'm a product manager for Oracle Primavera Cloud, in particular the risk part within that. So I'm not at a little startup, far from it, with Oracle. Yeah, I've been working in and around risk within the project space since about 2007, which is quite a while now. A lot of that was working with our older risk tool, Primavera Risk Analysis, and then in the last 3 years, I've had the role of product manager specifically on risk in Primavera Cloud, and yeah, also based in the UK here. Yeah.
Thanks, Dave. And yeah, really glad to have you on the call with us today. So I'm going to dive in and give you a little bit of an insight into some of the things in weather and construction that probably a lot of you know, probably a lot of you have experienced this. And I think there's this kind of concept that, weather is one of those problems that's just always been there. So about 50% of construction projects do suffer delay from weather. Based on this big report that was done, which was kind of a meta study looking at lots and lots of projects all around the world, it identified that actually this increased project durations by about 21% on average. So of course you might have a really big project delay, or you might have something small, but that's still a significant cost and in terms of the extension of a project. And so if you kind of just try to boil it down to one number, weather probably costs about 9.5% time cost of the industry, which when you look at that from a global perspective is a lot. And I think that's the kind of the high level numbers, and where it really starts to I think come into the reality. What people think about is kind of winter working. So whenever I've spoken to planners, they really think, okay, winter is when we're going to get hit, and that's why we want to try to plan and avoid that time for our concrete pours or whatever it might be. And this graph I think does show that in quite a nice way, where clearly the other 3 seasons you can have much better potential for productivity output. Winter on average much lower. And I think what's interesting is what the variability of this graph might look like in different locations, because clearly depends on where you are as to what that seasonal impact looks like. But I think that really nicely summarizes where I think the historical view of weather has been in the construction industry. And this is another really interesting chart from a study that I found after looking at that previous one, which was quoted, which was kind of looking at what are the influences of kind of labor-based productivity rates in construction. And if you just combine all of the weather types together, it is the biggest influencing factor. So almost 45% of the productivity rate of an activity is influenced by the weather. Then you've got work type and where that work is happening. But I think, again, that's something that you maybe don't necessarily think about, just how big of an influence it might have. And of course, temperature is the kind of the top identified one there. So if we just were to drill down a little bit more into, okay, what role does temperature play in terms of that productivity rate? Of course, in some cases, it might completely stop the way. If it snowed, ground's frozen over, you may have 0% productivity. But actually, if you look at, and they did quite a number of different studies, and again, this is a meta-study analysis. So as the temperature drops, so does the productivity rate. And even once you get over a certain temperature, you do start to see some productivity rate drops as well. But it was a recent webinar that I did on health and safety, and we were looking at data which actually showed that okay, there may not be such a big drop in productivity from higher temperatures, but the accident rate goes massively up when you see rising temperatures. So it's you replace your slightly better productivity with slightly more accidents in those hotter, warmer days. So I think that's kind of a really nice overview of how weather has influenced and starts to influence productivity rates at the moment. So we're going to get much more into other things, but I will hand over to Dave now, who's going to just run through some of the common approaches that he's seen through his work. Dave.
Yeah, thanks, Josh. So here we're seeing on the screen, the overall user goal that we typically encounter. So as a project manager at a general contractor, I need to know the likely impact of weather on my project schedule so that I can confidently provide a realistic finish date to the owner. So this is not to say that only general contractors are concerned about the weather and that owners or clients or even subcontractors aren't concerned, but this is the perspective that we'll be coming from through this presentation. For owners or subcontractors, it might just be a slightly different viewpoint. One other important factor that we will not really get into today, mostly because of the time, and it can be a sizable topic on its own, is the impact of the contract. So who carries the risk of the weather impacts, where it lies, and is it with the owner, the client, or the contractor? So what we are going to talk through here is introducing a framework around maturity in how organizations consider weather in their construction schedules today. So this is based on conversations and requests from a broad range of organizations. We'll talk about each of these a bit more over the next few slides, and then later in the demo, we'll also refer back to this and talk about it from this perspective. So the first level, level 1, do nothing. Ignore the risk and hope for the best. Obviously, it's quick and simple, but it's got some pretty big disadvantages. There are certainly some organizations that are doing nothing at all, right? And if the activities themselves are free from any extension, they haven't got a weather adjustment baked in, as we'll get to in level 2, the project is almost certain to run late. As any weather impact at all on critical activities is obviously going to drive a project delay. So not a place where anyone should really be. And we're going to quickly move on. So level 2, this is still a fairly simplistic approach, right? It's to simply add a bit more time or padding to individual activities, changing their durations. But it becomes difficult to do this with any real accuracy, especially as the project moves in time due to delays or any other reason. So you've now got at least some consideration of risk taken into account. Still pretty quick and simple, but the main disadvantage is you've got no account for schedule changes and activities moving between the seasons. You're typically still relying on gut feel, which means you can either be putting in too little padding and therefore the project is still going to run late, or too much and your plan is really unnecessarily later than it need be. So see a little bit more what we really mean by that in this next slide. So on the left here, we have the base schedule without any consideration for weather. And on the right, we can see activities. So within the construction place in particular, where we've got these little blue elements that are adding up, and the total project is getting pushed out from 12 to 13 months. If an activity was due to be in August and slips a few months to December, if you're using this approach, though, would you really then update that activity to account for the fact that it's now in winter versus summer? Usually the additional time for weather is not as visible as it is shown here on this screen. The remaining duration for an activity when you're in Primavera doesn't have a base and then a weather component to it that you add on. Also, as soon as an activity is extended, it will typically fill up to take that time. So if construction staff are working on activity that's meant to be finished by Friday, they don't usually work flat out in the first half of the week and say, okay, I'm done by Wednesday. They typically will work slower and fill the time that has been set. So even if the weather is good, the project is already built in and effectively, in principle, accepted the slip that you might have got because of weather. Let's say you go for a simple approach of adding 10% to all activities. Activity 1 was 20 days and you add another couple of days, 22 days. But maybe activity 1 is lucky and it doesn't have any weather impacts. But the activity, as mentioned, will typically still expand to take that 22 days. Activity 2 was maybe also 20 and added 2 to 22 days. This time it is impacted by the weather, but not just 2 days, it got hit by 4 days. So the activity ends up running over those 2 days based on the finish date that you were expecting. So between them, you've got a 0 and a 4, they average 2 and you added 2, but overall you end up running late. Okay, so moving on, level 3, using weather calendars in the schedule. So just to highlight, this approach is not using risk analysis and Monte Carlo simulation. We'll get to that later. It is simply running the scheduler again, but with adjusted calendars. Exceptions are added to the activity calendar to represent weather down days that we could likely expect to impact the project. So, you know, we've got a consideration for risk still, and now we are taking into account the seasonal nature of the weather. Rather than adding time to the activity and adding non-working time to the calendar, it is specific to that period, right? So you're adding more days in winter than in summer. The disadvantages of this, you know, you usually required to then go off and do a whole load of data gathering on weather at that location and then trying to convert that into calendars, which can be pretty onerous and error prone. Although obviously we'll see how EHAB helps with that area in a moment. And it has deterministic assumptions. You know, what is the average weather in a particular month, which we'll come back to and talk more on later as we go through the demo. Level 4, so here we now do move on to risk analysis, where we do Monte Carlo simulation of the schedule, where weather risks will again impact the activity calendar, but this time we run the scheduler, say, 1,000 times, with the number of down days due to weather varying from one iteration to the next. And we build a picture of the range of possible finish dates for an activity and then the project as a whole. So first two items on here, the advantages are the same. We're no longer relying on this deterministic assumption, such as the average weather. Worth pointing out that while we're specifically talking weather in this discussion, it also works alongside your other threats and opportunities that you might have in the risk register too. It does still mean you need to go off gathering that weather data and converting it, unless you, of course, then move to level 5. So this is what we believe is the most mature approach, running a risk analysis. So you're not just working with averages, you're seeing the full range of uncertainty in your forecast, but also having the inputs to that risk analysis be from a data-driven source that is specific to that location. So we've now got the advantages the same as previous, except we've also got location-specific data-driven inputs. The only disadvantage really is, you know, you need a risk analysis capability and you need a weather data platform, which is where, you know, Primavera Cloud and EHAB together obviously step in. So working your way up this maturity ladder is certainly, I think, where people want to try and head. It's not always that straightforward though, right? So whether you're looking at that level 3 with the schedule or running risk analysis, this is the, you know, the challenge that people typically see. You know, a lot of organizations are aware of the shortcomings of those lower level approaches, but it's not always that easy. So you've got maybe your project managers creating the schedule and they want to understand the impact of weather. So they, you know, depending on the approach that they're taking, they're either creating weather calendars or weather risks. And the project manager realizes, okay, I need to input the probable lost working days. I need to know for roofing activities in November, how many days am I likely to lose? They quickly realize they're not really very equipped to answer that question. So they go off and they, you know, start trying to gather some data, right? Maybe they go online, search for some weather data. Maybe in a bit, they manage to find a useful website where they can download some of that data. I've got all the wind speed data in London, let's say, but you then need to spend a lot of time in Excel trying to convert that from wind speed in miles per hour or kilometers per hour at location to, you know, well, how many times does that mean roofing activities are going to get stopped in days? It's not a trivial exercise at all. And all too often people give up and therefore don't get to those higher maturity levels. So the aim, if this is the current state, if we shift this onto the future state with where we're trying to get. So the project manager creates their schedule and they want to understand the impact of weather. Now they define the location, whether that's clicking on a map or entering longitude and latitude. Then they go and get this connection to this weather feed, this weather source, EHAB here. They define or they confirm the thresholds based on local regulations. So for example, if we're talking about working at heights and roofing activities, what is the sort of wind speed beyond which we will not work? We then are able to get a generated feed, whether that be calendars or risks, in terms of probable lost working days. So I know how many days I'm likely to miss out for roofing in November. And then, depending whether you're looking at that level 3 or level 4, you can run the scheduler or run the risk analysis to see the impact on the schedule and much more confidently report on those schedule timelines to the owner. Okay, so I think, Josh, ready to move on to our next.
Yes. So you know the drill. You know
Yeah.
the drill, folks. If you scan the QR code in the top left, we're asking this question. So about the levels of maturity Dave has just been speaking about. Which level of maturity do you think best fits where you are today? We're just curious to kind of get a read from the room. If there are some EHAB customers there, then looking forward to some level 5s being voted on there. But equally, if you're at the lower levels as well, that's fine. We're obviously here to try to help shine a light on the benefits of that and what we can do to kind of improve that as well. Okay. Looks like my LinkedIn messages to EHAB customers has gone quite well.
I was going to say, yeah, impressive number of level 5s in here. It's good.
I think there's about 38 people on the call, so I'll give it a few more seconds to let people to kind of have a vote. Don't worry if you're not going to contribute. I think you can still scan the QR code and answer it later as well if you want to. It'll be really valuable data for me and Dave. We'll do a little post afterwards about some of the results that we've captured during this talk as well. But I think it's quite interesting, isn't it, Dave? Level 3 being the main one. Is that what you were expecting?
I was expecting a lot more level 2s, to be honest, than we've got. So it's good that we're a little bit further along those lines. Yeah, definitely. And
that's
yeah,
that bias
very
data
good.
set again. The biased
Yeah.
pool of people who are keen on the weather.
Yeah, exactly. We need these results for the people who don't come to these webinars as well, right? Yeah.
Yeah, it'd be interesting to see what the answers would be for a more general view of the industry. But no, that's really great, folks. Thanks for answering. And I'm going to crack into this topic now. So we've already seen how weather is clearly impacting, and I know that there's lots of things that can already kind of be done to try to prevent that impact. But clearly, we all know that changes are happening quite quickly now. So the obvious one being temperature. You can see on this graph. So the line at the bottom is the long-term average, and we're exceeding that. And the curve is getting steeper as well. So there's been some recent research by climate scientists where they've basically realized that they've underestimated how quickly things are going to change as well. So not to scare you, but that is the reality that we're living in. And of many ways that temperature impacts other weather types, particularly spoken about one is this one, which I recently found out. So, of course, the hotter the atmosphere gets, the more water vapor it can take. So for every degree of warming we experience, we get about 7% more water vapor that the atmosphere can hold. And one of the impacts of this is humidity. So, of course, we sweat to cool ourselves down, and it's very bad for human bodies to be at high temperatures for a very long time. But unfortunately, even in the UK, and here, if you can see, it's kind of a UK, China, East Asia, and a global average, we're seeing that these days where you have this combination of high heat, high humidity are going up in not a great direction. And so that has implications for people who are going to be working outside in these conditions. And what this is called is a hidden heat wave, where maybe it's not necessarily going to be a hot day, but it's this combination of hot and humid. And of course, there's lots and lots of research out there. So, one of the most devastating impacts from climate change is this increase in heavy rainfall. So I won't go into the detail of it, but the long and short of it is there's more of these extremely wet years. There's more rain on average, and there's more of these extreme rain days where you get 50 mil or more, which would be a absolute torrent downpour that would almost certainly cause damage on your site were that rainfall to be impacting you. And what this actually means for construction, we've done quite a lot of research now into the implications on actual schedules. So over the last 20 years, if we look at projects as if they happened in 1990 versus 2020, we can see there's been an almost 10% increase in the number of down days on average, the expected number of down days that you might experience. There's also been a widening between the best and worst case scenarios, so just more volatility by about 9%. But the scary number there is the likelihood of these types of very extreme delays where something's going to be radically pushed. That's gone up by a large margin, and that really is because of that extreme more extreme events occurring, and of course rainfall being one of those leading ones. We've done, I could go, and again, this is Dave, this is another topic that could be a presentation in and of itself, but just to highlight again, on the left are some graphs just looking at the asphalting type activity. It's a good question, Alan. It was on so the 200 days was an average of the projects that we analyzed. So I don't have the specific number for you, but from I think it was about 3.5 years, 4 years was the average of those projects. But if we're looking at the asphalting type activity, these graphs on the left just show the average number of down days that those types of activities would be experiencing. So again, you can see a sharp increase around 2010, 2015. And we've been doing a white paper recently looking at the Gulf Coast. And if you look at the average downtime across all different types of activities across all of these locations, you can again all see that there's a trend happening across every single construction activity type where the likelihood of impact is going up as well. So these are just some of the implications that climate change is having on scheduling. And so, of course, me and Dave want to try to explain and talk about level 5 and that kind of EHAB Oracle integration and how that can benefit you when you're trying to make some of these assessments. So what I'm going to do is explain how the EHAB model starts to work. And so it all revolves around picking a location. So that can just be one point on a map, or if you have a project that's quite a large area, you can pick multiple sites. So we work on HS2. That's a project which clearly you're going to want to have multiple locations for, because the weather is going to be different at one end of the railway to the other. And this is data that we have available anywhere on Earth. So regardless of where you're picking a point, we have data for it. The current level of granularity for that data is about 9 kilometers grid, but we are currently implementing a 1.5 kilometer grid, which would be for Europe and North America. And actually specifically for temperature, we have the ability to go down to a 90-meter grid. So that's using elevation and artificial intelligence to be able to massively increase that ability to identify what the temperature might be. You know, let's say you're tucked away in a valley somewhere where there might be a microclimate. There are these ways and methods that we can now use to kind of get even more granular, so that you're getting accurate data for exactly your location. And we approach things in I guess a particular way. So we have about 50 years of historic data for that global data set, and at the moment about 11 different weather types. And we're really leaning into using these machine learning techniques that allow us to identify what's the best method for calculating these long-term forward-looking trends, as well as kind of training itself on data as the project is ongoing as well. So that's a kind of a focus of ours, is to make sure that we are deploying those techniques. And on the screen there in the middle, you can see is the list of satellites. So that big long list, I tried to get the whole list in there, is all of the different satellites that we access in terms of the data sources that we have. And so that just means that there's global coverage, even for places where there isn't ground stations. So you can see the map below. Those are all the ground stations that we pull data from, and it's combining that satellite and ground station data and that machine learning kind of techniques that allow us to kind of get that broadest coverage that we can. And there are also lots of other really big companies doing lots of things with AI, and we're trying to, whenever they're releasing new things, so for example, Google's DeepMind have GraphCast, which is now the most accurate forecast data, beating all of the other supercomputer models. So we lean in, and we've been trying to take some of the ideas and approaches that they use as well. So trying to just give you a sense that we want to have the best in class data set that you'll always have access to. And from a platform perspective, the way that we've designed EHAB, and this is potentially new to a couple of people who are joining, who are maybe customers of ours who haven't seen the platform over the summer. We've now got a new methodology which tries to help lead people through a process, so that weather risk just becomes a process that everyone can deploy, depending on the size of the project and the risk that's associated. But you can just go through a step-by-step process, and even if you haven't used the tool before, it's quick and easy and simple to get the information you need out of EHAB into Oracle, or whatever approach that you're trying to take on your project. We also have this new thing called workflows, so that if you are an organization who
wants to deploy the same technique across all of your different planners, you can build your own workflows. So you might say, well, currently we've got a level 3 approach. How can we make that level 3 approach better? And there'll be a step-by-step guide for that. Maybe we're looking to get to level 5, which uses risk analysis. And so you can create a workflow that includes that as well. And so we're trying to design the process to make it easy for everyone to kind of follow that step-by-step guide. Now, one of the most fundamental parts of, and this is really the crux of kind of what me and Dave are going to kind of focus on, which is for every activity in your schedule, we want to apply a set of thresholds. So perhaps traditionally, whenever we've been speaking to planners, there might be a winter calendar that gets applied, or something that kind of, it maybe is generic and is applied to all activities. But what we want to do is apply thresholds which are specific to the activity type. So on the screen, I've got my concrete activity. It's got different thresholds for temperature, min and max, wind speed, snowfall. You can add and take away as many of these as you want. We've got a default set that we've used and spoken to people in the industry about. And that gives us a pretty good understanding of, what the thresholds should be for this activity type. You can also see that there's an activity code here. So what we generally encourage people to do is use like a coding system in their P6 schedule, so that we can know which activities are which when you upload your plan to EHAB. That just makes the process much easier, so that we've when we're running our model, we know what type of activity we're actually looking at. And I guess the final thing is that we aren't, when we run our big model, we aren't specifically modeling weather, because it's really, really difficult to do. So if we've got a multi-year project, what is actually much easier and more accurate to do is to model the success rate of that activity. So instead of saying that it's going to snow on the 3rd of January 2029, we just say, well, what is the likelihood of my concrete activity being successful on any given day? And so that gives us a much higher ability to identify the correct number of days. It's just a much more accurate approach that we found. And so just before I hand over to Dave, one of the things that you'll do in EHAB, and again, anyone who's an EHAB user will be familiar with this, but you'll have assigned activities to your plan. You can do that manually using this interface, or ideally you've already got your codes in there. And this will be the kind of screen that you identified. So we know what are the activities that are weather dependent and which aren't. And so when we run our model, we're able to then run the simulation based on that. And something that we're going to share at the end of the webinar for anyone who's attended is actually the EHAB codes that you'll be able to upload into Oracle, and you'll just be able to have those codes by default in your system, which will just speed things up. So thank you to Dave for doing that piece of work. I guess once the model's run, and the final thing I'll say before handing over to Dave is there are lots of insights that the EHAB platform offers. So as much as there's the ability to export the calendars, as we're going to go into detail on, you can see lots of information in the platform, and you can make tweaks, adjustments to your plan so that you don't have to bring data back and forth necessarily. You can do something in EHAB, and once you're happy with potentially any mitigations you might want to make or any changes you might want to make, then you can pull those changes back into Oracle. But there's a number of dashboards there. But what I'm going to do now, Dave, is hand over to you so that you can walk us through.
Yeah, excellent. Thanks, Josh. So yeah, here we're seeing an example of a construction schedule. So I'm in Primavera Cloud in the schedule app, same as you might be familiar with in P6, if you're using the web version of P6 at least. I can see, the WBS, some of the groupings down at the bottom here that I haven't expanded, like foundations and masonry, roofing, etc., as well as some others that I've expanded, the activities, the coloring, helping me see which are critical or not. I can see right at the top, I've got my project starting 4th of September through to 10th of March. So, 6-month project in this particular case. So here I've got a reminder up at the top about the different levels. I'm going to walk through this level 3. Really, it's probably like a 3+ or a 3.5, as we're going to be using the data-driven weather calendars to feed in here. So I'm going to use this option on this QSRA weather calendars option. I can choose from the drop down. I've got the Oracle Primavera P6 option, although here I'm going to be going through the schedule app in Primavera Cloud, which is, very, very similar. So in Primavera Cloud, unlike P6, actually, you can have scenarios within a project. So these are really just copies of the schedule, if you like, for what-if analysis. Perfect for this use case. So I can take the file, this XCR file that is exported out of EHAB, and I can import it. I could choose to put it straight in as a project, or as I'm doing in this case, I'm going to import it as a scenario into this particular project and put it into, this scenario name. I'm actually looking at weather at a place called Zeebrugge in Belgium. Is the location where I'm getting all of this data. I'm also actually making use of the baseline capability in Primavera Cloud a little as well, as we see here. So here's my project. I've got the start and finish dates. These first two columns here are for the current schedule, so no account of weather. And then alongside, I've got the weather start and finish dates alongside in blue. That's after running the scheduler, including the calendars that are provided by EHAB, with exceptions for what weather down days we can expect to see on average. If you do weather schedule slips, I can see this on the variance between the start and the finish of these two. I can see it graphically on the Gantt chart here as well. You'll note the remaining duration for any activity is exactly the same. So the activity duration isn't changing. It's when the start and finish might be based on the calendar that is changing. So just to make sure we're clear on what this is showing, if, for example, I take a look at this activity, this prepare site, la-di-da, rest of it, activity name, it's going from the 11th to the 12th of September in my current schedule. I can see in my weather version, it's going from the 11th to the 13th of September. So there's no variation in the start, but there is a one-day variation here in the finish. So this is because when I look at the particular calendar that is getting used, I can search for my EHAB calendars in here. I've got this particular calendar that is getting using for site mobilization activities, which is the WBS that I was within. I can see September the 12th here is an exception. This is a non-working day that EHAB is adding based on this particular type of work at this location in Zeebrugge. So the activity that started on the 11th can't finish on the 12th. There's no working time, and it finishes on the 13th instead. Hence the slip. And you can see there's lots of different calendars in here. It basically takes the name of your existing calendar, and it takes the different type of work that we've got. I jump to another one here for roofing, for example. You can see lots more exceptions. I'm effectively losing a day a week all the way from June through to November, and a lot more in the winter months here in December. So here's a summarized view of all those different calendars connected to the different activities of what the weather is doing to my project as a whole. So you can see overall the project is slipping from finishing on the 7th of March to the 28th of April. Whether I look at this kind of milestone view or a summary up at the top. So this approach is pretty quick and simple when getting trusted data from somewhere like EHAB here. It does have the downside of a couple of simplifying assumptions. So firstly, some assumptions need to be taken in adding those exceptions to the calendar, like you saw, blanking out all Thursdays, for example. Secondly, a set number of calendar exceptions are added. So typically based on the average or the mean. Of course, the actual weather days could be more or less than that particular amount. And it gets us onto the topic of when we're relying on averages and how risk analysis kicks in. So there's a very good book that I read quite a few years back now that I'd recommend by a guy called Sam Savage called The Floor of Averages. Bit of a play on words from the more traditional phrase, the law of averages. And you can see here a quote from the book. So plans based on average assumptions are wrong on average. So it's usually quite hard for us to put numbers in our plan other than best guesses or averages, whether you're talking about the durations of the activities themselves or the number of days, in this case, that we're likely to lose in a given month. You can't usually say, well, it could be between 5 and 10 days very easily. So you have to pick a number and you say, okay, let's go with 8, and you put that into your plan. So this book goes into detail in this area, but in layman's terms, so it's very easy reading, no need for any statistical background. And it shows some very good examples where you can run into a lot of trouble by relying on average numbers. the little drawing on the right here is a play on this, right? You've got a project manager who's trying to cross a river that's on average 3 feet deep. So he assumes he's okay to cross, but doesn't realize that it's, 1 feet for most of the crossing and 10 feet deep in the middle, and he's not a very good swimmer. So as mentioned, there's a very smart guy called Sam Savage with this quote here. A not so smart guy, I've added my own little quote on top of this. This particularly has an impact when it comes to project schedules, and especially when you've got parallel paths, as I'm going to try and show here. So anytime you've got parallel paths or parallel activities in your schedule, whichever of those paths ends up overrunning a little, it's that path, it's that activity that becomes your critical one and pushes out the completion date. If you only had your activities in series, maybe some would be a little bit early and some would be a little bit late, and overall they might cancel each other out. But as soon as you've got activities or paths in parallel, let's say path A is early, but path B is late. Well, it's path B that drives your critical path, right? If it's the other way around, it's whichever of them is late, pushes out your critical path. You're always going to lose. The average of these down in green here is 6 months, but you can see the red just follows whichever is longest, and it's always longer than the 6 months. So you're always in trouble whenever you've got activities in parallel here if you're relying on averages. So a way that we can get over this and step our way through this maturity here, get a bit more sophisticated and overcome this floor of averages is to use risk analysis. So Oracle Primavera Cloud allows you to bring together the complexity of your schedule and the complexity of modeling weather. So we add a third risk type. So we have threats and opportunities, and we're adding weather risks, where we define the periods of non-working time for each weather risk. So threats and opportunities are your more typical risks that you might be used to seeing in a project risk register. You add in your probability and impact, maybe your cost and your schedule impact. So weather risks work differently, and that rather than increasing the duration of an activity, say like the way a threat would impact it, we increase instead the non-working time in the calendar to represent those days that are lost due to bad weather. So similar to when we went from level 2, where we were saying that we're padding those activities with a longer duration, to level 3, where we were adding non-working time in the calendar. But now, rather than making this simplifying assumption and entering an exact number of down days for a particular calendar month, we are able to put a range around that value to represent the uncertainty in our weather forecast. So here's an example where we're now in the risk register. We're looking at a particular risk, this weather risk, and we're looking at the definition of that risk. So we can see it's defined in monthly periods, and we can see, for example, anywhere between 0, 1, and 2, they're going to lose in terms of the number of lost days in the summer months, where we're saying, could be a lot, could be 10 to 20 days, something like that. But the point is that we're putting a range around those predictions, not a set value. We can click on the calendar to also visually see what this looks like. So rather than just looking at a table of data, you can see a lot more clearly. We know we're losing a lot more time, these probabilities here in the winter months than we are in the summer. You can also look at an individual iteration. So in this particular case, you can see there's a lot more time being lost in the winter months than in the summer. But these are now a particular iteration that will feel one of the 1,000 that you might run, 1,000 times that you might run the scheduler, but works in a very similar way to before, right? So if you've got an activity that is due to start Tuesday the 12th and run for 3 days, it will hit the 14th and say it's a non-working time, and it will instead run to the 15th for that iteration. But we can have lots of different iterations. I can click on this and say, okay, here's another version of the schedule of the calendar, sorry, that might happen. Here's another version of the calendar that might happen. So when we run a risk analysis, we're sampling this calendar over and over again based on those ranges that were set, 10 to 20 days in December, let's say. And, we're running the scheduler to see how the individual activity is being impacted by the non-working time, and then how does that build up into the project as a whole. So to demonstrate this, we're going to run risk analysis on 2 identical builds. They're both building schools. One is effectively running the summer. So I'm starting in April and I'm finishing in September. 30th of September is my finish date. This is one of the outputs from risk analysis. So I've ran 1,000 different times the scheduler with different calendars impacting as we look through. I can see that I'm never hitting my deterministic finish, the finish before risk None of the days were within that. I'm typically running into the first week or the second week of October. You know, this is the weekend where we're not working. I can see my P90 date, the date where 90% of the time we finished by, is 14th of October. That's 10 days, 10 working days later than the 30th of September. So this is what happens when I'm building my project over the summer. I've got exactly the same project, exactly the same activities, just made an entire copy, exactly the same weather risk even, but I just changed the start date. So instead of running from April through till September, I'm starting in October, and I'm due to finish, you know, before we take into account weather risk, on the 1st of April. If we look at the output now and see the range of finish dates, we can see, you know, we was due to finish 1st of April. We can see we're running into June here and creeping even a little bit into July. That pessimistic finish date, that P90 date, is out at the 27th of September. We're talking 61 days, working days of contingency now versus the 10 that we had for the summer project. So big difference in an identical project just based on when you're running the project. And here I've got a view that allows me to see both of those schedules side by side. So I can see, you know, the summer build, just looking at its start and then its finish. I've only got a couple of weeks slip for its, you know, its pessimistic finish date. I can see for the other project, I've got this 3 months of slip, same project, just based on whether you start it and build it over the summer period or whether you build it over the winter period. So that is, you know, how risk analysis works. The key challenge with this step 4 is this weather risk definition. Knowing how many weather days might happen for each different month, for each different type of activity, because some are more susceptible to particular weather conditions than others, and for each project location. You know, my simple example here of 2 schools, maybe at 2 different sites. So I need to grab data for the 2 different sites. So this is where EHAB helps us get up to this, this level 5. So another download that I can get is for Oracle Primavera Cloud. That will immediately give me a set of risks in Excel that I can immediately just import. You can see here the 12 risks that I've got. They're all open weather risks. I've got different tabs down at the bottom here. The impacted activities shows me the mapping between risks and activities. This is, you know, based on the process that Josh just talked through a little bit earlier, or could be using the codes to simplify that a little bit as well. But in particular, it's this data that we that are really after, right? So for one particular risk, for its different periods, how many down days am I likely to get due to weather? So no longer being, you know, down to an individual to go off and research and key in. I can get, you know, data-driven information, and I can immediately just import it into the risk register. So on the actions menu, there's an import option. I literally click on the button to download and click on here to import, and I get my 12 weather risks and all of that weather information immediately in here. We can again view that calendar visually if you want to get a feel for what it looks like, and go through the individual steps based on that information. So really, if we compare the 2 approaches that we're getting with EHAB data that we get out, on the left, the data provided is effectively the level 3 one here via the export of the schedule calendars, the P6 option that we chose. So, but this is looking at that after we've imported into Primavera Cloud and looking at the calendar view. So in this particular case, I'm looking at roofing. I'm looking at November 2024. And whether I'm looking at here or the little summarized view, I can see pretty quickly, you know, it's saying you're going to lose 9 days in November. On the right, we see the difference with Primavera Cloud and the weather risk calendars. So rather than saying exactly 9 days, you're saying, okay, we don't know exactly how many days. It's somewhere between 0 and 15 based on the data that we've got, and most likely is going to be 4. So we're aware of the fact that this forecast has got uncertainty around it, and we give it in the form of a range. And, you know, as you've seen, we can kind of step through. Okay, iteration 1, it just sampled 2, 4, a lot more, a bit less. You know, this is what we're doing as we run through the risk analysis. So hopefully it explains the difference between bringing in a deterministic schedule with some non-working time versus risk analysis, where the non-working time is changing for each iteration. So, you know, similar type of output to before. I can see the variability, the uncertainty in how the weather will impact the project finish. I thought my project before weather was going to finish 10th of March. I can see my P10 is, you know, a month later, 10th of April, 23rd of April, 13th of May. I've got more than a month spread between my P10 and my P90. What does this really mean? So if I want to be 90% confident in the date that I'm going to give. Say I'm a general contractor and I'm providing a date to the owner, or we're setting the contractual dates. If I want to be 90% certain based on the weather impact on my project, I should be looking at 13th of May rather than this 10th of March. That's 45 days of schedule contingency or time risk allowance that you're adding into your project. Interestingly, this target and target probability is something you can also add. This 28th of April, this is the date that we got using level 3. So if we take, the deterministic calendar, the 9 days, for example, that we saw for roofing, and we plug that in, the project finished 28th of April. Well, okay, 60% of the time, roughly, we will finish within that date. Or conversely, if you use level 3, you're still leaving yourself open to, nearly 40% of the time going beyond that date. And this is really the key difference between running risk analysis and using level 3. You're now making your decisions based on a confidence level, setting the date based on your risk appetite. We're focused on finish date here. If you're using resource and cost-loaded schedules, you can look at exactly the same type of output here, also in terms of cost. How much contingency should I be adding into my project because of weather and the cost impact that it will have because of extra equipment that we're hiring or labor that's on site still, even though it's a lost day due to weather. Another output that we've got here is this one that shows schedule and cost together. So I've got cost up the side, schedule along the bottom. Each dot on here is representing the 1,000 different iterations and the different finish date and cost pairings. Bottom left, I can see the probability of meeting that particular finish date and cost combination. So in this case, the date and the cost entered, again using the level 3 values, the chance of achieving I can see is actually pretty low. I get this green schedule contingency or time risk allowance showing the difference between the date deterministically before any risk and where I'm at. So I can either enter dates in here, or I can say, what is the confidence level I want to get to? If I want to be 80% confident, I key in 80, it will move these lines and it will change the amount of contingency that will be needed so that I can have a date and a cost that I then am 80% confident that I can meet. So again, it becomes much more about, we've elevated that discussion from how much weather risk to how confident do you want to be in the dates that you're committing to. Very useful information when you're agreeing contractual dates and looking at the potential of liquidated damages maybe later in the project. Some other outputs that you can get, I can look at this risk removal impact, a tornado type of output, which shows me which of the different risks are having the biggest contribution to how many days. I can look at that from a cost perspective as well. And I can see 15 days, 140,000. I can get those figures back in my risk register as well. So I can see, for example, it's the cast in place concrete piles in particular that is given me the challenges in here. So this wraps up really the section of our step through demo, if you like, here of the different maturity levels and how you can use Primavera Cloud and EHAB together. So hopefully that helps give a feel for the the integration between the two products.
Yeah, thanks, Dave. There is one question, but I think we can answer it at the end, perhaps.
Yeah.
Shall I take back over?
Yeah, sure.
So we're just wrapping up now, folks. So I just wanted to highlight one of our clients who we've been working with for a very, very long time. We've helped them kind of transform their approach to weather risk, going up the levels and basically enabling them to kind of create this as a standard process across their jobs. And so actually, we've been nominated with them as a finalist for Project Controls Innovation of the Year, because I think this is an important thing as we see climate change impacting projects more and more. We need to become more resilient to this type of event. And so, we're really keen to continue working with our existing customers and lots of others to improve the system and to make sure that this kind of approach can become streamlined and easy for people to deploy. So I know me and Dave are having discussions about how can we automate this even more, aren't we, Dave? Because we want to make it so that it, you can just run this type of analysis by default, where you don't have to necessarily even think about it. The model can just run and you get that value and outputs So just a few of the benefits. I think there's been a question in there from you, Alan, around the data itself. So of course, weather is a chaotic system, as I spoke about earlier, that the variability gap is growing. So that means that the best year where we have an amazing summer and the worst year where we have a terrible summer, 2022, 2024, is growing. And so therefore we need to make sure that we pull in as much data as possible, as bigger data sets as possible. And that's what we do, trying to bring that kind of accuracy when we're predicting downtime. So when we do our modeling, we look at a particular activity, where in 94% of the times we get the number of down days correct for that activity in a given week or a given month. On average, when that is then deployed in what we haven't spoken about, but contractual things, and trying to help contractors to get more time risk allowance or to maybe optimize their plan, then what we've seen is on average 10 days saved per year. And that could be, increased time risk, potentially helping them save that cost that they would have borne. We've also done an analysis kind of looking at some of the more traditional approaches. So it's actually not even a level that was on there, Dave. It's maybe 0.5, where you just kind of chuck some time risk on the end. So we've compared that versus EHAB and looking at the improved accuracy there. And once you get your, everything set up, it really can take, a very short amount of time to actually run this analysis. So of course, the first couple of times always takes a little bit of time, but what we see now is customers who are doing this on a regular basis are doing it very, very quickly when they're deploying activity codes to match. This is one of the final slides. I know, Dave, we were kind of thinking about some of the other benefits that are maybe from a client perspective as well. So I don't know if you wanted to comment on any of these things.
Yeah, no, definitely. I think, one of the things I best like about using EHAB as a data source, whether it be, the level 3 feeding into schedules, or the level 5, the risk analysis, is the fact that it's, it's neutral. It's impartial data from a neutral source. So it's not just something that the contractor has put together to try and, buy more time into that schedule. And the owner is going to then, question that and query it and try and pick a debate, right? You look at things like NEC, the whole aim of NEC is this neutral contracting approach. I think it very much aligns with that, right? That you've got this neutral capability that can get this data. Think about that from a bidding perspective. So if you're bidding for jobs, you can be now a lot better informed about the likely finish dates, and if the dates the owner is pushing for are realistic or not, right? The school example that we gave, like in one of the comments in the chat as well, right? As rightly mentioned, it's, are you ready for term time or not, right? There might not be this, I can just push it out by 2 weeks. But if you see, well, there's absolutely no way that you can make it for the term time, given the weather that you've seen at that particular location, you've now got the data that backs up that decision. And then it's up to you, do you want to make the decision to still go ahead and bid on that work, knowing that you're leaving yourself wide open for running late, right? You got much better informed to make those decisions. We're talking about predominantly around timing here, but the cost implications as well, right? And setting that bid price and how much contingency you put into your bid, etc. as well. And predictability, I guess it's an obvious one looking at this as well, right? Getting more increased confidence yourself as a contractor, more increased confidence that you can provide to owners around your own project schedules and ability to hit dates, which can only be better for helping your projects finish on time and budget, and better chance of winning future business with other owners, right?
Exactly. Yeah, exactly. And I know we're very running out of time, folks. So one last Slido. I know a few of you are in the process of leaving, but this is where we wanted to just get to around, okay, what level of maturity do you think you would hope to achieve in the next 12 months? So I know quite a few of you are saying that you're kind of on that level 3. Do you have a desire? Do you have an interest in getting to a higher level? And I know Stephen, Alan, Warren, there's a few questions in here that we're not going to have time to answer. So what we're going to do, me and Dave will go away, we'll answer them in text format, and we'll then send that email out so everyone has the answers to those questions as well, just because I think we're a bit pushed for time for answering them now. But if you do have more questions that you'd like us to answer in that email, then chuck them in the meeting chat right now. If you are able to answer the Slido, then just give it a little scan, I'm glad that there's lots of level 5s there. So obviously, yeah, me and Dave can help you think about what that level 5 might look like for you guys. What we'll also be doing is sending out a recording of this, and I will also send out the slides. I think it was Alan who's requesting it as well. So Dave, if you're happy, we can send out the slides as part of that email as well. Yeah, no problem, folks. Really appreciate you taking the time. And Dave, any final thoughts to wrap up?
Yeah, no, absolutely. It's always an interesting discussion. I was, slightly nervous given the number of level 5s we had at the start that it wasn't going to drop after going through the presentation. But yeah, no, it's looking good. And it's been good fun, Josh. And yeah, always happy to have a discussion with people to progress any of this further. I was about to say we've got our contact details as well, right? Cool.
Yeah, please reach out to us if you want to. And thank you so much again for your time, Dave, and for everyone for joining. Yeah, see you all at the next one. All right.
Yeah.
Thanks, everybody.
Bye-bye.
Have a good one. Cheers.